Hello and welcome. This video is going to be focused on the Nmap tool. What I want to do in this video is to go through and show you how Nmap works. We're going to go through some of the sample commands. We're going to look at packet capture files of all the commands. Going to compare all the different types of scans you can use Nmap for. And we're going to then at the end give you a challenge of some packet capture files to look at, analyze, and determine which Nmap commands will run. Now this is going to be an introduction video. There are a lot of things you can do with Nmap, and this video is only going to cover a small portion of them. Nmap is an extremely versatile and extremely powerful tool. This whole purpose is to give you a good introduction to it and get you comfortable looking at it and hopefully get you encouraged to use it more. The main objectives for this lab are, after completion, you should be able to explain both the purpose and the function of Nmap. You should be able to run a network sweep on a target network, perform some vital scans such as TCP Connect scan and the TCP SYN scan and identify how they work. You should be able to identify vulnerable and protected ports on a target machine, and also identify characteristics of a target machine such as the operating system and what specific services are running on specific ports. Some skills that you should be able to have: you should have some knowledge of using Wireshark. You should have experience reading some basic information from a packet capture file. Good knowledge of IPv4 addressing, knowledge of MAC addressing, and general knowledge of the TCP three-way handshake. Some of the skills that you will develop during this lab: you'll learn how to use Nmap to scan a target network. You'll learn how to use Nmap to identify live hosts on a network. You'll be able to identify which ports on a specific machine are vulnerable or available. You'll be able to determine, within reason, the operating system of the machine, and then also within reason determine what service is running at a specific port on a machine. Nmap was originally created on the Linux platform. In this demonstration video, I'm using VMware, and I'm using this Nmap on a Windows 7 system. So all the commands I'll be running will be looked at from the Windows 7 administrator perspective. So today I'll be running some Nmap scans, and we will be looking at the reports. Nmap is going to scan the ports, and it's going to report on the status of those ports. Now there are some different ways Nmap will report it, but the three most common will be open, closed, or filtered. If a port is reachable, it's active, receives connection requests, it will be considered an open port. If a port is reachable, but there's nothing there, nothing listening, nothing running, but it's reachable, it will be considered a closed port. And then a filtered port is when a port on a PC is blocked either by a firewall on the host or a firewall somewhere else in the network. So a filtered port means Nmap cannot determine if there's something there or not. So again, open, closed, or filtered. Here's the topology I'll be using for this lab today. You'll see that all four PCs are going to be virtual machines. There's all going to be connected to one switch. I have two machines that are running Windows 7. One at the top is running IIS. One on the right, PC2, is going to be the source PC where I'll be running Nmap from. PC on the left will be Windows 8. I'll be hitting this one a lot in the lab. And the bottom machine is a Fedora Linux machine. The first type of scan I want to look at is going to be what's considered a network sweep, sometimes called a ping sweep. What it's going to do is look at the entire range of a given network and find out what machines are available. It will do this by first identifying if it's on the same subnet or network as the target network. If it is, it's just going to send out ARP requests. If it's not, then it's going to go ahead and send ICMP echo requests. In addition to the ICMP echo request, Nmap's going to send a TCP SYN to port 443 of the target. We'll send a TCP ACK to port 80 on the target, and it'll also send an ICMP timestamp request to the target. The command for running the network sweep is nmap-s P followed by the target IP of the network and the CIDR notation. So in my examples, I'm going to be running nmap-s P 172.20.00/16. The packet capture file you can look at is going to be network_sweep. Okay, now I'm going to go ahead and run a ping sweep, or really a network sweep, and use Wireshark here, capture the packets, open up my command prompt, run my command nmap sp, and then the target network 172.20.0.0/16. I'm going to start the file, and I'm going to pause the video. Once the network sweep is done, we'll come back and take a look at the packet capture file. Okay, so let's take a look at this packet capture file. So here I'm looking at my time column. Here's 205 seconds, and I got about a little over 15,000 packets. And if you look over here to the right of the info, I'm down to the 172.20.25.151 IP address. If I go back to this command and my command prompt, I ran nmap sp 172.20.0.0/16, which means I want to scan for all 65,536 possible IP addresses in the 172.20 network. So looking back at my packet capture file, I can scroll to the top, and you can see where I've started on the 01, 04, 5, 6 down through, and then it's going to increment this third octet, the 1 network. Then it's going to go to the 2 network. It's going to go to the hop back and forth to the 1. Then it comes to the 3, the 4, the 5, 6, all the way down. And what it's doing is it's scanning for all those possible IP addresses they're going to answer. And again, looking back at my command output, you'll see here that the nmap scan report for 172.20.1.1 came up. It found a MAC address, and also listed, of course, as being from VMware. It found a response for the 1.3 and a 1.4, and then again it listed both of those as being VMware. And then down at the bottom here, my stats, and when I stopped the command prompt, it showed at 3 minutes 25 seconds had elapsed, and 4,097 hosts were completed. I found 4 up, and I had 4,096 that were currently undergoing the ARP scan. And all that means is it's going to break the destination network into increment sections. So each segment is about 4,000, or is 4,096 hosts. Now what I want to do next is find the replies for the machines that I know that I have. I'm going to scroll up here until I can find them coming from the 1 dot network. 1.1, 1.2, 3, and 4, the machines that I'm running. So let's scroll up to the top here, looking for the question of who has the 172.20.1, 2, 3, 4. Alright, so here we have who has 172.20.1.1, 1.3, 1.4, with 1.5, and below that you can see the responses. 172.20.1.1 is at that MAC, 1.4 is at that MAC address, and 1.3 is at that MAC address. So these are the replies that are coming. So now what Nmap is doing is building my network, looking at what's available, and here are the replies, placing the MAC addresses. Next, we're going to look at the Nmap TCP Connect scan. This scan is going to look at the top 1,000 most commonly used ports. It's going to attempt to complete the 3-way handshake, and if it does, it's going to send back an ACK, and then it will tear down that connection with a reset. The specific details for Connect scan. The source will send in a SYN packet, receives a SYN ACK in response, ports open. The source can send a SYN packet in, receives a reset and ACK in response. The port's likely closed or being blocked by a firewall. Other two options are sends a SYN in, receive an ICMP unreachable response, filtered port, or sends in a SYN packet, receives nothing in response, and that's going to be a blocked port, and again that's a filtered port. I'll go ahead and run that. So my command will be nmap lowercase s capital T 172.20.1.1. Packet capture file goes along with this is conscan 8 no firewall. Because I'm going against the Windows 8 machine, firewall right now is turned off. Okay, let's go ahead and run this TCP Connect scan now. I'm going to open up, start my Wireshark, open up my command prompt, nmap st 172.20.1.1. Pause the video and come back when it's finished. Now, let's take a look at this packet capture file that shows the TCP Connect scan against the 172.20.1.1 1 machine. Alright, here are my packets. About 90 seconds almost, a minute and a half. 6,175 packets being sent back and forth. I want to first take a look at a specific port. So I'm going to do IP source equals the 172.20.1.2. So I'm sending it from my target machine, looking at my target machine. And I'm going to look at the TCP port. And I'm going to look at this one being equal to 135, just a typical Microsoft source as far as communications are concerned. Alright, so now I'm going to find some here. Let's see. Right here. So the top one, I'm going to go ahead and follow the TCP stream, close this window, and you can see I have 4 packets coming across that have been isolated for this communication. So now I'm going to look at how Nmap is going to reply and respond to these packets. You know what I mean? But reply, I'm showing how it's going to report and record the ports involved. So the first one, we know we're sending TCP connect scans. If I come down here, look at the bottom, I'm going to scroll this up, look at my TCP, and I know I'm sending a SYN in, so there's my SYN turned on right there. Now everything else is off, and there's my SYN packet going in. That's from the source machine, the 1.2 running Nmap. The next packet is from the 1.1 machine, the target, and you can see here it says SYN ACK. So this is my SYN ACK coming back to my 3-way handshake. I can look at that one, there's the acknowledgement now set, and the SYN set. So again, the 3-way handshake, I expect to see a third packet, the acknowledgement packet coming back from the target machine. I'm sorry, the source machine, the 172.20.1.2 machine. There it is, there's the ACK coming back. So again, come down here, and there's the ACK number being set right there. So that's a successful 3-way handshake. Now since I've received a SYN ACK and replied to my SYN, I know the port's open, reachable, and is available. So I'll close this out. Now I'm going to do another one. IP SRC, again, is going to equal 172.20.1.2. And TCP port, this time one equal port 80, the web server. Let's see what happens here. If I look at this first one, again, I'm saying it's SYN in. Let me redo this. Make sure I get what I want. Okay. Now if I look at the first one coming in, my SYN packet being sent in, there's my SYN being set. What comes back is a reset ACK. So reset basically means the port is closed, there's nothing listening, it's not being blocked by a firewall per se, it's being reached but not being utilized. So say nothing's listening here because my 1.1 machine is not running a web server, so port 80 is not listening, going to respond to anything. So again, it has the reset being set. So that tells me again that that port is going to be basically closed or inaccessible. Now looking at the output for the Nmap connect scan, you'll see here in the highlighted area at first, the top, it says 990 closed ports, because those are the ones that I received the reset on. We looked at the port 80. So then it received the reset, it's communicating, but there's nothing listening, so it's considered a closed port. But we know that machine is available. Now below that you see the first port number in the port column, port 135 TCP. That's the one that I found where I sent the SYN and got the SYN ACK back. That was port 135. The state there is considered open. And again, this is when the firewall is turned off. Now let's go ahead and run that same TCP connect scan against the same machine, except this time we'll have the firewall turned on. Okay, I went ahead and I ran the TCP connect scan against that machine. This time I turned on the Windows 8 firewall. So now you see here on the scan report, host is up. All 1,000 scan ports on that machine are filtered, meaning the firewall is blocking access to all of them. Now we're going to look at the TCP SYN scan. What a SYN scan is going to do is going to send a SYN packet to a target. It will not complete a 3-way handshake, however. So if a target replies with a SYN ACK, Nmap says that port is open. Again, will not reply with an ACK. If the target sends a reset, then Nmap will consider that port closed. And if there's no response, Nmap will consider that port a filtered port. The command for this TCP SYN scan, Nmap dash lowercase s capital S followed by the target IP. So my example will be Nmap as dash st 172.20.1.1. Packet capture file is SYN scan 8 no firewall. Okay, go ahead and run the TCP SYN scan Nmap dash ss 172.20.1.1. Start the Wireshark file, capture it, and then once this is finished, we'll come back and I'll take a look at the capture file. So now we'll go ahead and take a look at that packet capture file from the SYN scan against a Windows 8 machine, no firewall running. On the left hand side, you'll see I have Wireshark here. I have the packet capture list, a little over 2,000 packets. The scan took just under 24 seconds long. On the right hand side of the window, I have the output from Nmap in the command prompt. And you'll see here there are 990 closed ports, which means there are going to be 10 open ports. So here's the list of the 10 open. You'll see it's port 135, port 139, port 445. Those are the standard Microsoft ports, basic services, and then the other ones are up in the higher range. You can do a quick Google search and find out what's going to be common for those Windows machines on that point. What I want to do now is go ahead and go to the left side. I want to look at the packets going in and being sent back from the target machine. So I'm going to do an TCP port equals 135. That's the first open port. Apply that filter, and you'll see here the SYN going in, and you'll see the SYN ACK being received. Now there's nothing else being sent. We're not going to complete the three-way handshake. There's no ACK going back. There's just going to be the SYN and the SYN ACK. So you can see here that the source machine is 21.2 and the target machine is 172.20.1.1. So the 21.1 machine will receive it and send back the SYN ACK, and then the sending machine will not complete that handshake. I could do this again, change 135 to 139, look at it again, another port, and again you should see the same thing. The SYN's going in, the SYN ACK coming back. And we're not going to look at it anymore. But again, the packet capture file is there for you to take a look at. Again, this is the SYN scan. Now we'll run the TCP SYN scan against Windows 8 machine with the firewall turned on. Packet capture file is SYN scan 8 with firewall. And now we're going to go ahead and take a look at that SYN scan, except this time Windows 8 will have a firewall. Same setup as last time. I have my packet capture file on the left, and on the right hand side of the window I have the command prompt output. Okay, now you'll see that the packets took a little about 37 seconds. On the right hand side you'll see that it looked at all 1,000 ports and they're all considered filtered. And again, we know that firewall is running, and that's pretty much what you would expect. Now if you look on the left hand side, I put my filter in, TCP port equals 135. We expect to see the SYNs going in, and since they're filtered, no SYN ACKs coming out. And that's exactly what we see. So that's proof of a SYN scan against a machine with a firewall running. If there were some SYN ACKs or some resets, you'd see some of those in this list, but they're not. Nmap can also be used to determine the operating system of a target machine. What it does is something called active OS fingerprinting. It sends in a packet and it monitors the responses from that packet. Now there are over 30 different tests that Nmap uses to try to evaluate and determine what the operating system is. It's not perfect, but it is pretty good. So the command is going to be nmap-O and the IP address, and I'm going to run it against one of my machines in my network. So run my command for the operating system scan, and I get two things in the results. First, I see that port 22 running SSH is open. It did run the scan on 1,000 ports. 900 filtered SSH is open. And the second thing I see down here is it's running Linux. It doesn't tell me exactly what version of Linux, but at least I know it's a Linux machine. And it's correct because it's running Fedora 17. The last scan I want to cover today is on version scanning. When Nmap runs a scan, it finds ports that are open. It checks a file that it has in its directory, and it reports whatever file, or whatever that file says is on that port number, the default service. However, we know that there are ways of changing what port something runs on. For example, you don't have to keep your web server running on port 80. It can be moved to a different port. So what I'm going to do is I'm going to run two scans. I'm not going to show packet capture files from. I'm just going to show outputs. The first scan I'm going to run is against a machine that's running IIS on port 80. And then I'm going to do a second scan against a machine that's running IIS on a different port. So we can see here that I ran the version scan, and it reports that port 80 is open, the service is HTTP, and the version is Microsoft IIS 7.5. I then went back to the machine running IIS, and I changed it so it now responds to port 23. Again, ran the Nmap version scan, and now you can see that it did correctly identify that port 23 is running the service HTTP version Microsoft IIS 7.5. During this lesson, you learned how to use Nmap to find available hosts on a target network, how to use Nmap to look at vulnerable or open ports on a specific host. You learned the differences between a TCP Connect scan and a TCP SYN scan. You learned how to use Nmap to determine a target system's operating system, and also you used Nmap to determine what service is running on a specific port. I hope this was both educational and enjoyable, and now you'll move on to the challenge.